What is electrochemical series? It is a series of elements or species with standard reduction potential values with the increasing order of SRPs. So, what are the series? All these are all active metals. 2, 6, then up from 7, hydro water, and here forms hydrogen gas, and we need to remember this series. This is our sheet. With respect to this hydrogen electrode, they constructed this series, and the reduction potential here or oxidation potential of this H plus is 0.00 volts. Water comes in 2 times. Here it undergoes reduction and forms water hydrogen gas, and here water undergoes oxidation and forms and gives O2. This is our electrochemical series with the increasing order of SRPs. Basing on this series, Li plus is having lowest SRP and F minus is having highest SRP. So basing on this series, let's see few questions. Na2SO4 aqueous solution. This is a metal, inert metal, which does not involve in a reaction. So they may ask, what are the products formed at anode and cathode? Or else, which one is going to reduce and which one going to oxidize? So, first, what is the basic condition? Anode, oxidation will occur. It is a positive terminal. We know these things. And the cathode, reduction occurs. This is a negative terminal. When the reduction happens, when the reduction potential is very high, high tendency to reduce, then reduction happens. That means SRP will be high. And anode oxidation when SRP is low. These are the basic things. So Na2SO4, our species is. So let's write down anode, oxidation, and cathode, reduction. As anode is a positive terminal, what are the species are going to wants to go to positive, negative species? In the Na2SO4, what is the negative species? SO4 minus. And as we are using aqueous solution, water will also go, as water has the tendency to oxidize and as well as reduce. So a cathode is a negative terminal. So positive species wants to go to negative terminal. What is the positive one here? Na plus, and water also. So let's see this table series. NA's value is, number is 4, and water value is 7. So what is the phenomena when we consider the cathode? If the SRP is high, that species undergoes reduction. So among these two, which is having more SRP values, because we are going increasing order of SRP. So compared to 4 number, 7 number is having high SRP. So what, instead of Na plus, water undergoes reduction. So here water, when we consider these two, SO4 and H2O, here water comes in oxidation. Where is that water? Here. The number is 21. SO4, 23. Then what is the condition in anode case? Anode, oxidation with low SRP. The species which is having less SRP value, that will undergo oxidation. So among these two, which is having low SRP, here also water. So let's see. Here oxidation of water is happening, and here also reduction of water only happening. So oxidation of water, if oxidation of water happens, what we'll get? Water oxidation gives oxygen as a gas. So water. So here, what is the oxidation state of oxygen? Here -2. From -2 to it is coming down to 0. So here 2 oxygens are needed. So multiply this one with 2. So 2 electrons for 1 oxygen. So for 2 oxygens, it's going to lose 4 electrons. And along with the electrons, how many H plus? 4 H plus. So this is the balanced equation in the case of anode. And the product is oxygen gas at anode. Then what about a cathode? Here also water. This water molecules takes the electrons and forms H2 gas. So if you write here 2 H2O and 2 electrons, H2 plus, how many oxygens are left? 2 OH minus. Charge is balanced. Yeah, 2, 2. So here product is. So see this magic. We are using Na2SO4 here. Here we are not at all discussing any water thing here. We are simply mentioning that aqueous solution of Na2SO4. But not Na or SO4 is going to oxidize and reduce. But water is going to oxidize and water is only going to reduce. That is based on this series. Remember one thing, whenever water undergoes oxidation, gives oxygen. Whenever water undergoes reduction, gives hydrogen gas. This is one of the example we can say. If same thing, if you take CuSO4, then let's take